Hello guys, this is lecture number 3 of current electricity for boards. Okay, so in the last lecture we have discussed till Ohm's law, what are its limitations. Okay, we also discussed about how can we write down the formula for resistance. Yes or no? Correct. Okay, now in this lecture we are going to derive few other things. Okay, so the derivation of Ohm's law in a vector form. Check. So Ohm's law in vector form. Ohm's law in vector form. Okay. So, do you remember N I was NEA VD? Okay. I equals to NEA VD. VD over here is what? Drift velocity. Now, we can write I by A, we are transferring this over here, equals to VD. Yes or no? Correct? Okay. So this is known as what? J. Your current density. J. Current density. Okay? Chaliye. So J equals to NE VD. How can we write VD? How can we write VD? Ask yourself. We can write it in the form of what? Electric field. Yes or no? How? E tau. Sorry. E tau by N. Yes or no? Correct? Very good. Right? E tau by N. Okay. So now we can write J equals to, we can write J equals to, बोलिए, N, yes, E square E N E square E by M. I'm so sorry. I just want to write in a different way. N E square by M into tau into E. Okay. So do you know that electric field is a what? Vector quantity. Electric field is a vector quantity. If this is vector quantity, LHS should also be a vector quantity. Okay. So this is known as what? Vector form of Ohm's law. This kachra over here, NE square tau by M, okay, is known as what? Conductivity. Conductivity, sigma. Okay, sigma is what? Conductivity. Okay, so that's why we write current density equals to conductivity into electric field. Okay, J equals to sigma E. This is known as the vector form of Ohm's law. Again, a very important derivation. ठीक है? Please look carefully. How did we do it? I equals to NEA VD. After that, we are writing I by A, that is current density. है ना? I by A as current density equals to what? NEVD. Now, how to create electric field on the RHS? How can we create electric field on the RHS? By writing drift velocity in terms of what? Electric field. Correct? After writing that, your electric field is there. Now you can simply do it. Yes or no? Correct? Very good. Okay. हो गया? बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया. चलिए. So now we are done with this Ohm's law in vector form. Now, आज. So now let's discuss on. अच्छा एक चीज तुमने लिख ली कि भाई J को लिख लेना बाद में So J equals sigma E is your Ohm's law in vector form. अब आ जाए ना, let's discuss this resistance in depth. Very important topic, resistance. Okay, so how did we define it? R equals to rho L by A. Okay, R is rho L by A, where rho is what? Your resistivity. Resistivity. Okay, चलेगा. L is the length of conductor. A क्या होगा भाई तेरा? A cross section area of conductor. बराबर? ठीक है. चलिए, ठीक है. So now R depends on what all factors R depends on. Resistance depends on. It depends on material, whether it is a copper, whether it is a gold, whether it is a silver, whether it is a iron, whether it is a aluminium or something else. We all know, correct? Okay. So R depends on material and obviously dimensions. On dimension, what is the length of the conductor, whether it is twice, thrice, what is the area, is it 5 times, what is this radius, is it 5 times, 6 times, we are getting it, how thick or how thin the wire is. Okay, so R depends on materials and dimensions of conductor, correct? Okay, what is its length, what is its area, it also depends on it, correct? Very good. Okay, now third thing, out of this resistivity, length and area, resistivity is the core property of the material, out of which resistivity, when we write rho is known as what? Resistivity. Okay, resistivity, rho is the core property of material. Rho is the core property of material. It only depends on what? Your conductor. It will not change with dimension. So in grade 10th, if you can remember the very, the standard question was this, if you are converting gold into 2A, you are stretching the gold, let's say by 5 times, okay? By some method, you are changing the length and you are changing the area. Will it affect the resistivity of the material? Answer is no. Resistivity, it only and only depends on what? Material. If it is gold, if you are changing its area or length, it will still remain gold, correct? So it will only and only depend on what? It will only and only depend on the material. It won't depend on the dimension. I hope this whole thing is clear. Now, to make this whole point solidified, okay, we can use equation as well. Okay, so do you know that resistivity is nothing but 1 upon conductivity? Okay, resistivity is inverse of conductivity. Okay, now we can discuss about this resistivity, or we can write resistivity as 1 upon conductivity. From page 1, I am just writing the value of conductivity, that is n square tau by m, n square tau by m. 1 upon conductivity will be resistivity. So over here too, you can see it does not depend on the dimension of what? Your conductor. It only and only depends on what? The material. Mass. What is the charge of the mass? What is the charge density? Charge of electron and relaxation time. Are we getting it? Correct? Okay. So this is resistivity. Now, if we are discussing on resistivity, why do we discuss a lot about it? Because if we are able to understand completely about this resistivity, we can also, discuss in depth about resistance. Because R is rho L by A. LA you have played a lot in grade 10, but now let's play with resistivity. So, if we are able to understand completely about resistivity, we will be able to define, or we will be able to feel this resistance better. Okay, so that's why we generally discuss more about resistivity. So resistivity, that was point number third, fourth. Okay, so point number fourth. So you can see it depends on electron density and relaxation time. So in general, rho depends on temperature. It depends on temperature. Okay, resistivity will change with temperature. Just giving you some clue. Resistivity of conductor or metal will increase as temperature increases. Okay, resistivity of metal increases as temperature increases. That's why the resistance of the conductor increases with temperature. We will discuss why. Okay, secondly, resistivity of semiconductor. Resistivity of semiconductor decreases as temperature increases. Okay, something that we should know, there's something we should remember, and anyways from grade 10 we all know, if we are increasing temperature, semiconductor, its resistance will decrease. For metal, its resistance will increase. Okay, अगर फोन गर्म होगा तो ज्यादा रेजिस्टेंस क्रिएट करेगा, है ना? तो अगर मेटल गर्म होगा तो क्या होगा आपका कि yes, it will have more resistance. चलिए, done. चलिए. Now let's talk about it. Why this whole game is there, and how can we say for sure, and how can we explain why the resistivity is changing with temperature? So firstly, resistivity for metal. देख अच्छे से. So the formula over here is nothing but m upon n e square upon tau. M upon n e square by tau. Okay, so look at the denominator. Huh? So n and tau. N is what? Charge density. Tau is what? Relaxation time. So it will depend on this. So as temperature increases, ठीक है, अगर temperature increase किया, then obviously there is an atom. Let's say iron is there. Already it was in the state of Fe+2. Let's say ferrous. Now it is giving one more electron. Now it is converting into ferric, Fe+3. Okay, so they are saying कि as temperature increases, yes, current density will increase, because now in the given volume you are increasing what? Electrons. But it won't be significant. Why? Because already you have a lot and a lot and a lot number of what electrons in the given volume. So in given volume already you have very electrons, okay, very much electrons. Charge density is already higher. By increasing the temperature, the charge density won't increase appreciable amount, and it can increase to 0.01%, 0.02%, है ना? But as temperature increases, the relaxation time it decreases. Why? Now the electrons, they are more energetic. You are increasing the temperature, now they are more energetic. At low temperature they are less energetic. It will take some time. But at more temperature they are more energetic. They will collide again and again. So the relaxation time it decreases. So what happens, as temperature increases, then yes my friend, this electron density increases थोड़ा सा, but relaxation time over here it decreases. It decreases. So overall the denominator, it is increasing or decreasing? It is decreasing. Overall the denominator is decreasing. Overall the denominator is decreasing. That's why the resistivity increases. Are you getting it? Thus, resistivity increases as temperature increases. Okay. Now, on the same ground, let's discuss about the resistivity of the semiconductor. Resistivity of the semiconductor. Again, writing the same thing. Okay. Now, you cannot change mass and the charge of the electrode, right? Okay. So, charge density and relaxation time will be changed. Now, think about it. In semiconductor, if I compare the electron density with the metal, they are almost like million times lesser than the charge density as compared to metal. They are million times. Just giving you one number, if you have 1 CR, 1 crore electrons in the metal, then you will only have 10 electrons in the semiconductor. Are you getting it? That much difference. Million times lesser. Okay. So basically when you increase the temperature, the charge density will increase. Why? Now in the atom the electrons are revolving, right? They are getting energy. So now they are getting more energy. Now the electron can eject. Are you getting it? Now your charge density will increase. Yes, in semiconductor, now the atoms, they will lose more electrons. Thus the charge density will increase. Yes. Okay. So, and you will say, yes sir, so what? Over here the charge density was increasing and relaxation time was decreasing. So same thing will happen over here. Yes, you are correct. No problem. But the sign matters. Over here the charge density was increasing a bit. Very thoda sa. But relaxation time was decreasing a lot. Over here, yes, you can say so as temperature increases, then yes, and tau. Let's discuss about it. It will increase more. Okay? The charge density will increase a lot, whereas this relaxation time will decrease relatively, smaller. That the product over here, it will increase. Okay? So the overall denominator is increasing, so that's why thus rho decreases as temperature increases. Okay. I hope this whole thing is very clear to you. Why resistance of the metal and the resistance of the semiconductor changes, why the resistivity increases for the metal. If resistivity is increasing, resistance is increasing. Okay, so with temperature, why in metals the resistance increases, whereas in semiconductor, why with temperature the resistance decreases. I hope this whole point is clear to all of you. Very good. Dhanjendra, are you bored? Yes, sir. The answer is always yes. When you do something wrong, answer is sorry. All scripted answers. No. Done, bhai? Okay. Okay. Now, that was point number 5. Point number 6. Point number 6. Okay. So the curve. In last year half yearly, they asked on this curve, so very important curve, resistance versus temperature. Okay, so if we are doing for 3 things. First is R, copper, okay, which is nothing but metal. Nichrome, so it is a metal. Nichrome is alloy, and over here we are doing for semiconductor. Okay, check. Instead of resistance, let's write resistivity. We are discussing resistivity. Anyways, the same thing will be there for resistance, but fairly. Okay. Now, for copper, with as we increase the temperature, the resistivity increases. So the curve, it goes like this. Okay. It goes like this, upward opening parabola. For nichrome, it's a constant line. Okay, the temperature increases, but in a linear way. Okay, nichrome is an alloy. Okay, so the temperature increases in a straight line way. Whereas in semiconductor, yes, you are all correct, it decreases like this. And so they ask in the half-yearly examination, that is, how can you draw the curve of resistivity versus temperature. How the resistivity is changing with temperature. So I think this year too they might ask anything from these three graphs. So very important thing. Okay. Done, guys? Very good. Very easy to understand, right? We are discussing the same thing from past 15 minutes. Blah, 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 blah. Okay. Now, that was point number 6. आजा point number 7. Point number 7 हम लोग क्या लिख सकते हैं? देख कि R changes as R0 1 plus alpha delta T. Okay. So R changes like this. R equals to R0 1 plus alpha delta T. So R is what? Final resistance. R0 was what? Final resistance at temperature T. Instead of writing it this way, you can write it this way because in books it is written like this. T minus T0. मतलब वही है. R equals to R0 1 plus alpha into T minus T0. R is what? Final resistance at temperature T. R0 is the initial resistance at temperature T0. ठीक है, कोई बात नहीं. Alpha, this is important. Okay, so this is the what? Coefficient. How? This is the coefficient of resistance, है ना? और temperature coefficient for resistance. Temperature coefficient of resistor or resistance, है ना? ठीक. So clearly we can say from this equation, देखिए, if for metal, if resistance is increasing, so obviously alpha will be positive. Correct? If alpha is positive, the whole equation will increase. Correct? If resistance is decreasing with temperature for what? Semiconductor. So obviously the value of alpha, it should be positive or negative, your call. Yes, it should be negative. Correct? Okay. So we can write this, that is K alpha is positive for metals and alpha is negative for semiconductor. ठीक है? You can write one more equation which is almost as similar as this, so need not to worry if someone is asking you the resistivity. So it will be same thing, rho equals to rho naught 1 plus alpha T minus T naught. Same thing, okay? Same thing. Instead of resistance, we are writing rho. How? Because rho L by A. So L and A, L and D, L and D, they are cancelling out. That's why we can directly say. In the same manner, the resistivity will also change. Correct? Okay. Done with the very important thing. Numericals will be asked on this whole formula. And the numericals we will make a very separate video. This is only the theory video, so that's why I'm not making you solve. the numericals at this in this whole lecture videos. Okay, चलेगा. So maybe this would be the last lecture of this whole series where we will kind of make you solve the important questions over there. Okay, चलेगा for boards. So now the last point, 8. This is something that you already know. R in series, R in parallel. R in series is what? R1 plus R2 plus R3 dot dot dot. Correct? This is the series circuit. R1, R2, R3. You want a picture like this, where this is R series and this is V. Okay? First thing. Second thing, on the same graph, can we discuss about parallel thing? R parallel, it will be, bolo 1 upon R parallel, something that you already know from grade 10. And so on. Correct? What picture do you want? You want this picture. ठीक है भाई? आज this is V, R1, R2, R3. Now you want to write like this: R parallel and over V is current. Correct? Okay. So in series, what is same? Ask yourself, in series what is same? Current is same. Current is same. And over here in parallel, what is same? Potential is same. ठीक? चल. Okay, now please, so we discussed everything about Ohm's law, about resistance, this, that, blah, blah. Okay, very good. Now, moving on to the next this topic of this lecture, that is, and the final topic of this lecture is that, like, not of this chapter, of this lecture only. Okay, so I think almost 6 or 7 minutes are left. So we can write potential difference across battery, resistor. Okay, so what is the potential difference? अच्छे से देखना कि when we move from, so point 1, if this is the case, okay, let's say potential at this point over here, this is point A, this is point B. Okay, so if the voltage of this battery is V, okay, so let's say we are moving from here to here, we are jumping from here to here. Okay, we are moving in this direction. Obviously, we are moving from lower potential to higher potential. Yes or no? So our potential will increase by a factor of V. Okay. Or we can say VB, ऐसा लिखा करो कि VA, okay, VA, it was the potential of this point A, okay, Now, when you cross like this, you are adding potential V to yourself, right? Plus V equals to VB. Now, you are reaching at what point? B. VA was already there. Now, when you are jumping like this, the potential will increase by V equals to VB. Right? So, it finally comes out to be VB minus VA equals to V. Okay? Are you getting it? Correct? So, this is the thing. Okay? I'm not confusing you with this whole equations. I'm just writing in words. Okay? So, potential increases by V. Okay? In second point, if we are doing the reverse thing, let's say we are moving over here. We are moving in this fashion. We are going from higher potential to lower potential. So obviously over here can we say potential decreases, potential decreases by negative V. Okay? So potential will decrease by negative V if V is this thing. I hope you are getting it. Over here the potential will increase by V, over here potential will decrease by negative V. Correct? Okay. चलिए. ठीक है? Now, third thing, very important thing, current flows from higher potential to lower potential. Okay? चलेगा? So it means what? कि over here see, current is flowing from higher potential to lower potential. Higher potential to lower potential, we should add one point outside the battery. Outside the battery, it is flowing from higher potential to lower potential. But inside the battery, it is flowing from lower to high. I am not writing that point. I hope this whole point is clear. Okay? चलिए. Current flows from higher potential to lower potential outside the battery. Okay. Now, point fourth. Point fourth is this. That is this resistance. Okay. So, if this point is A and this point is B, and VA is the potential over here, VB is the potential over here, R is the resistance, okay? And current over here that is flowing is I. Okay? So, funda is this, potential will decrease by IR across the resistor in the direction of current. Let's discuss that. अच्छा एक मिनट over here please do not write negative V, you might get confused. ठीक है? So potential decreases by V only. ठीक है? Otherwise you will say negative V, negative, so that's right. So over here potential decreases by IR across the resistor. Okay, across the resistor in the direction of current. Across the resistor in the direction of current. ठीक, चलिए. Potential decreases by IR across the resistor in the direction of current. These are the few rules that if we are able to understand it, then we can move on to the next topic, which is Kirchhoff's law. Okay, otherwise we cannot just touch that topic. Okay, so quickly revising all this thing. If we are moving through the across the battery, if we are moving like this, potential increases by V. Over here, if we are moving like this, potential will decrease by V. Okay, now if current always flows from higher potential to lower potential outside the battery, we all know. Okay, and if we want to calculate the potential difference across the resistor, it will be IR. So potential will decrease by IR in the direction of current. Okay, so over here we want to say this, that is VA minus IR equals to VB. Okay, so potential at B, okay, it is decreased by IR with respect to A. V over here, if you are moving over here, so potential will decrease by IR. So negative IR equals to VB. I hope you are getting it. Okay? ठीक है भाई. So now this is the end of the lecture 3. If you are wondering how we will use it and we will do that, so this is the topic for means, advanced and NEET. All these topics in questions, we will do n number of questions based on this. So these all rules will be crystal clear over there, but try to remember these things. Okay, if you are able to remember these, you will have no problem in the entire chapter. But if you are failing to revise all this, then you will be in great trouble. Okay, you might always be wondering ki, okay, why IR, why not negative IR, why negative IR, why IR, why V, why not negative V, why negative V, why not V. Okay, are you getting it? So you will be wondering over there. You might also be, so please, all these 4 rules are very, very, very important. Okay, so by V decrease by V. Over here, current flows from higher potential to lower potential outside the battery, and over here, the potential of V, it will decrease by a factor of IR. Okay, or we just want to say V minus IR equals to VB. Okay, in the direction of current, the potential decreases. Thank you so much, guys. Have a nice day. Thank you.